Hi, I'm Chris Madge from Queen Mary University, London, and I'm going to talk about incremental game mechanics applied to text annotation. So first of all, just a little bit of background. Games of purpose, as I'm sure many of you are aware, are the solicitation of human work or effort as a byproduct of play. So in this example here, these players are coming together to wash a car by firing water balloons at the car. The prototypical example of this is the ESP image labeling game, in which players come together to label an image by providing image labels, and when they match on the label, they score points. That's the win state for the game, as the label is unknown. The task, however, that we are working with is one of text annotation. So more specifically, part of speech tagging. These annotations are used to train natural language supervised learning systems, and they feed on through a pipeline. So in this example here, we can see the nouns, verbs, and pronoun highlighted in this sentence. This would inform the next step of the pipeline, which would identify mentions, and then on to co-reference resolution, where the entities identified by the mentions are linked together. Now, this inserting text annotation, unlike images into a game, is not such an easy fit. There's many design constraints. So the obvious solution might seem to be, well, we take an existing game and we just insert some text into that game, and we have the players play the game. For example, here, they could shoot at the labels. But the problem we run into right away here is orthogonal game mechanics, where shooting at labels and being good at labeling don't necessarily match up. If the player is bad at shooting, but is actually capable of providing us with good labels for our text, we will still end up with bad labels, as the core mechanic is not actually text annotation. So this rules out modifying a lot of existing games. There's a similar problem with ludic efficiency, where many games deliberately problematize their interfaces. Okay, this doesn't really match up with what we want from digitized tools. We want their interfaces to be as simplistic as possible and efficient as possible. We don't want to have a player press a fast sequence of keys to provide us with a label. Another problem is cost. Many games have quite high budgets, and when using text annotation in a game, for a game with a purpose or for education purposes, we need to have a cost that's ideally lower than other approaches, whether that's producing learning materials in the context of serious games, or whether that's crowdsourcing using something like Amazon Mechanical Turk for providing labels. Another thing is we want our gameplay to be infinite. So if we're having our players come along and label text, we don't want them to be limited to the 8-hour story that we produced, or we don't want to, going back to my previous point about cost, have to produce story or narrative in line with the amount of text that we want to annotate. And we want to reach a broadest audience of people as possible. So it needs to be accessible, easy to pick up and put down. And there I come on to clicker games. Now, I've already heard a lot about clicker games, so this conference, some great summaries on that. So I'm just going to summarise that very briefly with respect to our approach. Clicker games originally are a parody of Ville games and heavily utilised the free-to-play revenue model. And from there, really, there's a lot of interesting design properties that have been distilled down to clicker games, as you can see here in this diagram, which I supplement a taxonomy. We think these are quite uniquely suited to the challenges that I described before. However, clicker games, particularly the parent genres, are widely criticised, which perhaps partly motivated the parodies in the first place. So there's several things that we had to be cautious of and think, future work needs to be cautious of in applying this approach. So there's multiple dark patterns here, which have appeared in the news a lot lately, including temporal patterns such as playing by appointment, pay to win and pay to skip, and also social capital-based features in which people's friend circles are effectively used as content in the context of a game. So these are all things we avoided in our experiment. We also deployed our experiment specifically to games portals that allowed us to specifically say the game was of this type, an incremental game, so we could be sure that our players were cognizant of the experience that they were going to receive in playing the game. So the first step then was to adapt the clicker game loop. This is like a fundamental loop that's core to these type of games. And the main change here is the action step. We wanted to keep, as I said before, the annotation as the main part of the game. So they select ingredients from a jar, and they use that to select the word classes and then apply tokens, labels to tokens. For the rest of the step, we remove a lot of the interaction, so it is focused around the annotation process. So there's no waiting; it's a non-blocking game. They don't have to interact to harvest their rewards. This is another common pattern. And there's the common upgrade step in which the player makes a purchase, typically from a shop, with the virtual currency that they've earned from their previous interactions. This is what that looks like. So this is WordClicker. It's wordclicker.com, and you can go and play this now if you like on your devices. It's currently live. So at the top here, in the middle, we've got the ingredients jars. And those jars are the word categories. And the tokens below are where the player provides the labels for us. So they select the appropriate word category and then click on the label. Off to the right, we have the shop where the player can purchase upgrades. And to the left, we can see the status of the player's game. To motivate the player to fully explore the labels, the more ingredients they have, then the more their cakes are worth. The upgrades modify the rate at which the cakes are produced. So in our experiment, as I said before, we deployed this to 3 games portals: Congregate, Newgrounds, and itch.io. We wanted to test this amongst a discerning audience of real gamers. And we applied metrics adapted from free-to-play performance indicators to evaluate the success. I should say historically in recent games, the focus on evaluation is around the accuracy rather than player engagement, retention, or recruitment. So there's not a lot of data with regards to this, and part of what we're trying to do here is create a much more game-like experience for annotation. So the average session length we achieved was 27 minutes and 17.3 seconds, which I think is really quite good. We have a power law distribution, as do many of these games, in which the minority of the players provide the majority of the effort or time. And that's also common for many games adopting the free-to-play revenue model, field games, and indeed clicker games. And the players weren't just looking at the graphics. We did actually have quite a high level of judgments provided by the player as well. The players, we had 45.85 judgments over the lifetime of play, with many players returning for multiple sessions. There's also some evidence to suggest that players were learning as they continued to play our clicker game. There's no filtering, aggregation, or any other processes taking place here. This is the raw data, but there's some trends to say that they're possibly learning, or at least becoming increasingly familiar with the task. You can see here the bar chart has we have 200 players at the very start of the game, and they slowly drop off as we get through to round 20. And the lines here shown are the accuracy, precision, recall, and def measure. So I'll leave you with some key points here, and the URL for the games at the bottom there. I'll welcome any questions.
Thank you, Chris. Any questions? There's one over there. Hi, Juha Hamari from Tampere University. Thanks for a very interesting presentation, and there was a lot of interesting stuff in it, the free-to-play games and all unethical stuff, which I wasn't completely sure why you framed the paper around those, since it's a very interesting games with a purpose anyway. But my question would be, did you in any way test which mechanics you put into the game affected your dependent variables? Or was it just one big game and then you looked at the KPIs just as an aggregate for everyone?
It was one single study in this case. Yeah, with one set of mechanics which we designed by looking at the prior literature on clicker games and working out intuitively what would seem to be the best initial design. To this at this time, we haven't experimented with the various different options that exist for clicker game design now.
Yeah, I think that might be a very interesting future avenue to
absolutely
test which mechanics create
the impact both on accuracy, learning, and recruitment, retention, etc. I think absolutely very interesting.
Thank you.
Okay, we've got time for another question.
Hi, Helen Walk, University of Illinois, Urbana-Champaign. It's a really interesting talk. I was just curious about the accuracy. It seems pretty low. I was wondering if you could comment on that and whether you think that's an issue, potential issue for the future.
Sure. So, with this being completely unfiltered raw data, without any kind of players being removed, if this was in a setting in which we were trying to gather annotations, then there'd either be some pre-filtering or post-filtering in terms of A, removing players, or B, the data would be subject to some kind of maybe probabilistic aggregation in which we'd try and determine which players were good players, put that together, take some kind of voting process, and then extract the final response from that. But this is just raw players, so this includes people that might have just come along and been trying to break something or just clicking randomly, and players that were, had a serious interest in the game. If we were trying to extract data from it, then that's not been a study so far. This was really just about kind of the recruitment and engagement, and perhaps this is kind of like a bonus. There's perhaps some promise that this could be used for training or possibly in that context. Thank you.
Okay, and there was a final question over here, and maybe Stuart can set up.
It's on? Okay. ZTubes, New Mexico State. My sense from this was that a lot of like the design considerations were sort of like around like avoiding the pitfalls of these sort of like pay to not wait.
Absolutely.
Game. And when we've done like this taxonomy of idle games, a lot of it was centered around like ignoring a lot of those games, mostly because like How Clicker was like, whatever, it was positioned as like a satire of those types of games. And so since a lot of those games sort of like center on like waiting as like the core thing, and all the upgrades are around like changing your sort of positioning to the waiting, I was just wondering, could you talk a little bit like how the upgrades work in your game?
Yes,
how like waiting centers into that?
We didn't want waiting in there. I think so. Waiting and sessioning has a lot of promise, I think, actually for it. But then there's the ethical impact of that as well. But also we wanted to have players. A lot of those games, they deliberately make it so you have less interaction as you progress through the game. You purchase an upgrade and it reduces your interaction. So we tried to modify the design slightly in that the interaction kept on going. So effectively what our upgrades do, aside from increasing the speed, is increasing and decreasing the player's interaction with the game. So that when you purchase an upgrade, the ingredients start going down faster, and you have to provide more ingredients to keep the factory, if you like, working, keep the machine ticking along. And then there's another set of upgrades that you can purchase that slow it down again, all while increasing the speed of the game. So you're managing the interaction in which you're comfortable providing labels. The speed of the interaction, you're comfortable providing labels, but the loop is as I was describing, non-blocking. So there's no point in which you stop providing labels, but you can slow down, you can purchase something to slow down the speed at which you provide labels.
That's interesting. This kind of thing around like centering you making choices about the level of interaction you want to have.
Yeah.
Cool. Thank you.
Thank you.
Okay, thank you, Christopher.